All right, welcome everyone. What do you call sad cheese? Blue cheese. All right, let's talk about cheese. Cheese.
We'll be here all week, folks.
So I came across the Swiss cheese model when I was talking with someone about what we are doing around proactive open source risk management. And I thought, hey, this would be an interesting perspective to look at. The Swiss cheese model was developed in around 1990 by James Reason. And it's used for thinking about risk in systems where we have multiple things, multiple layers of defenses that we can implement, but they all have holes, they all have shortcomings, and we try to keep the holes small, and when one layer fails, have another layer as backup. That's the idea, and by thinking through a system through all the different layers and what the holes are and how they might align and catch each other, it helps us get a better picture. And so, how do we apply this to open source? Well, there are a couple questions that we can start asking, and I'll start walking through the first couple questions, and then I have homework for you to do the rest. Yeah, you didn't know you were going to walk away with homework today. You already have heard me, I'm Georg Link, I'm an open source strategist, director of sales at Bitergia. My mission is to make open source more healthy and sustainable. So all of the good work. This presentation is based on a blog post that we just published today, so feel free to read up on it. If I'm not going into detail on some of the things, some of the layers and holes, the discussion, we have that more refined thinking in the blog post. So applying the Swiss cheese model, let's start with the first question and ask ourselves, what are the hazards or threats when we use open source software? When we think of a software supply chain, the attacks are on the rise. The Sonatype found this 700% increase in malicious packages that they found over the last 2 years. So there are bad people discovering that they can use open source to attack us, and the damage is on the rise and projected to rise even more. And Gartner predicts that by this year, about half of the companies will have faced a software supply chain attack. So there is an attack vector open through our open source software supply chain. So let's ask ourselves, what are the critical assets, processes that we want to protect? Well, there's many different things. We want to protect our servers, our data. We want to protect the users that we have, our employees, uptime, all of that. When we don't do that, in the case of SolarWinds, we saw it took about 11% of annual revenue for these companies to resolve that software supply chain attack, which once it hits the bottom line, it becomes very painful. So we want to make sure to protect ourselves from that. So what are the different entryways to get into our software supply chain? We just talked about SBOMs, and we're coming back to this. When we use open source software in our software, and we've seen over the years this is increasing. Developers love to use pre-built packages and libraries and take why should you reinvent the wheel, right? So take the direct path to develop something new. And so 70 to 95% of software includes open source software. Software is essentially everywhere. Open source software is part of our commercial offerings, but most of the open source software is actually hidden away in the dependency tree, further down. And the problem is when we don't know what is all hiding in our dependencies, then that is unknown to us, and we cannot assess the risk. Hence, software bill of materials. Let's create that inventory of what we actually put into our software. This has gained a lot of attention, especially since the Executive Order 14028, and the CISA has done a lot of work around standardizing our understanding of SBOMs. Before that, the SPDX working group predates this, so SBOMs is no new idea. It's been worked on for quite some time. It is getting more and more attention to do this work. The Cyber Resilience Act says if you are using software in any of your commercial products, you have to do your due diligence. And how can you do that if you don't know what's in there? So SBOMs are becoming more important. Now let's think about the defense layers. Okay, so we are taking in open source software into our products. We understand that we have this. What are our defensive layers? And there's a great article by the UK government on what the current best practices are. And so inspired by this article, we are summarizing this in 4 slices of cheese or defenses. Or I was talking to someone earlier that they use the metaphor of air filters. Either way, we have these 4 layers. So let's talk about them one by one and what the holes are in each. One layer is to create this inventory, to create an SBOM, which gives us a starting point for deeper analysis. Once we know what we are using in our software, we can start analyzing it. License obligations is one of the very first applications for SBOMs, making sure the licenses we have are compatible and we can use them and we can comply with all of the obligations like sharing any modifications that we are making when we share the binaries, etc., etc. The problem is when we only use SBOMs that there's no analysis. Also, if anyone has experimented with different tools for creating SBOMs, they will find that different tools generate different SBOMs. There is no way right now that we have complete data. That's my understanding from everyone who has done it, because I've never actually built an SBOM before. So if you have found a better way, let me know. Another layer we have is vulnerability scanning. This is where we take the software, the components, the libraries, and we run them to software composition analysis tools. We look at known vulnerabilities, CVEs, and there's a lot of good vendors out there that have been doing this for many years. There's really good tooling around this. Shortcomings, or the holes in this layer, is that we will not catch unknown vulnerabilities or unknown patterns of attack. We may also be overloaded with a lot of notifications from these tools that some of the warnings are, it can become a lot when you have tens of thousands, hundreds of thousands of dependencies. Also, it's reactive, because unless someone has found something, then we don't know. It might be too late. So let's talk about project health as the 3rd layer. This is what CHAOSS is really good at. Knowing the health of an open source project and a community. We have 89 metrics, we have metric models. Understanding from a proactive perspective how a community is doing, are there stewards, are there maintainers, is the project being taken care of, and are we doing the right things? Are we supporting these projects? Especially when we talk about CRA readiness, there are a lot of standards still to be defined and what does compliance look like. But the gist of it right now that we can go towards is do the right thing, use the best practice in industry, then you will have an easier time once we actually know what CRA compliance will look like. So, but again, there are holes in this. Sometimes we have poor data about open source projects. Some of the information that we want is not available, like which organizations are engaged, if someone just used their Gmail address. There's sometimes challenges around reading the metrics, and of course, once we start measuring things, people start behaving differently. They're gaming the metrics, as we call it. The fourth layer are internal policies. We need in companies rules for what is responsible use of open source and what is not, which licenses can be used, which cannot, that the scanners are used, that we have CI/CD pipelines. There's a lot that we put in place within companies to have the responsible use of open source. The problem or the holes here is people use workarounds. They cut corners. We have human error, just the natural part of doing work that happens. Also, some policies are put in place without the proper tooling to have data back them up to drive the decisions. So they are sometimes more aspirational policies. So when we put all of this together, the next question is, how effective is each layer? And I will pick one of the layers, the one that I know the best, the project health layer, and we'll talk a little bit about how good can this layer be. The idea, to recap, is a healthy project today, or the level of health, determines whether in the future the project is going to be sustained and healthy and thriving or abandoned. So we can make inferences from today and judge the risk in the future. There are several, I'll call them inefficiencies, in the project health layer. We have a lot of different metrics that we can choose from. The definition of what is healthy, there's no standard definition around it. If you want to be involved in defining a standard, we have been talking about this in the CHAOSS community as well. The data sources are fragmented. Not every project is on GitHub, and some of the discussions are on Slack and behind firewalls or behind wherever. The scale of dependencies is upwards of tens of thousands, hundreds of thousands sometimes, that especially when you look across all of the software in a company, it becomes very, very wild to look at. And often the tools are reactive rather than proactive, and again, there are no standards like from a CRA readiness standard perspective yet. So if we take this is something that we have been working on at Bitergia, using Grimoire Lab as the source for the data, taking SBOMs from our customers, so we know which repositories to look at, and like we were just discussing, ideally the SBOMs have the upstream Git repository in them. We can use that to build, and we call it the risk radar, build a score, and I'll show you how this works. We take every component that is in the SBOM and look at a set of metrics, then normalize them so we get a single score for each component. So we take all of the different ways that we can look at health, combine them in a way to get one score, which then allows us to aggregate them. Again, there are blog posts on more about how this works. And right now we are looking at providing this data in two ways. One is a dashboard, interactive dashboard. Like here we have Kubernetes Golang dependencies, and we see amongst them low, medium, high, very high risk, how many of the dependencies are in each category. And we can break this down further into the how many packages by each type of metric that we have. And so one thing that I find fascinating is Kubernetes being a super widely known, mostly healthy project. The bus factor for the underlying dependencies is pretty high risk here. So a lot of the dependencies only have one maintainer or one active person doing a lot of the development work. So we can start to see better and at scale how our dependencies look from a project health perspective. We have experimented with single vendor risk. You may have heard that some companies change licenses to license rug pulls. That's no fun. So what's the risk there? Vulnerability risk. We're experimenting with speeding up. That's what the Grimoire Lab 2.0 development is coming in. The other way to look at this is shifting left. It's the ICD time. So giving developers early feedback when they are working when they submit a new commit, the CI/CD pipeline kicks in, and then there might be 3 stages where we have, first we create the SBOM, we get the file, then we get data about the dependencies that are in the SBOM, and you can see here like an output of the aggregate data, and then in the third step we apply thresholds and the risk model and weights to calculate a score. And this is the score I was talking about earlier. So those inefficiencies that I've talked about, we've been experimenting with how to we improve that. One is we have the model taking all the many metrics that we could be looking at, choosing a few that are meaningful, and building one risk score, so we reduce the information overload. We are doing research into thresholds. What does a healthy project look like? What are good metric numbers? Then Grimoire Lab is collecting data from many different data sources, so we solve the fragmented data sources problem. Grimoire Lab 2.0 does much better at scaling, so we can process tens of thousands of repositories. We have the dashboard and CI/CD integration so that we can proactively and reactively have the data and drill into it and analyze it. And then we can also anticipate, based on current good practices, what we should do, where to invest our resources, which will help with things like CRA compliance, I believe. We can argue about that over at the social tonight. So when we apply the Swiss cheese model, what we want is a diverse set of layers that they address many different aspects so that they can catch each other's holes and complement each other. And these layers, as they are presented, came out of the research the UK government had published, so we can argue whether this is diverse enough. And to continue, I'm going to give you the homework. Okay, fine. This is the takeaway slide. But really, where do we take this next? I encourage you to play with the Swiss cheese model. I hope this is a helpful way of thinking about the risk in open source. And you can check out Grimoire Lab, play with it, or Augur. Join the conversations in the CHAOSS community. We are a community of practice where we talk about these things. And then, of course, join us for the CHAOSScon social right after the closing. Thank you.